All right, folks, today's lesson talked about two ideas, but there are ways to measure location, and that was percentiles, which also deals with cumulative relative frequencies, and Z-scores. So we have two short activities today. The first one is just the front side of your paper, so it's all the way through here. And what I'm going to have you do, since we didn't have to collect data in class individually, it was already here, I'm going to have you go ahead and complete this first part. And once you get to the bottom of the front page here, you'll stop and then you can watch the video to talk through each of these just like we did in class. One thing I'm going to tell you ahead of time right here, when you get to this number 3 on the graph, I want you to draw it as a bar graph, even though your video from last time showed cumulative relative graphs as line graphs. We're going to talk about where the points for those line graphs actually go. So I just want you to do a histogram bar graph for this part, and then we'll go on top of it when you come back to the video for notes. Okay, so I want you to pause the video and answer those questions 1 through 3. Okay, then you can press play. So the first thing on here asks you to find the percent of heights that are less than or equal to a number. So if you count this here, we've got 1, 2, 3, 4, 5 because we do count or equal to, and that ended up being 25%. This right here, when we say less than or equal to a value, is called a percentile. So I want you to add this on. Remember, if you add this on in a colored pen, it's going to help you know what we added in later and the items that I want you to know. Okay, so if you need to pause the video to grab something, that's great. But this is your percentile, and how we would write this is we would say Ariana is at the 25th percentile for her height. And that just means that she's on the shorter end of the class group, which we can see from the data, and more specifically, answering the question here, 25% of the class is shorter than her. Okay, not that much. Then your height, you're going to fall at a different number than this. Whatever your height is what you fill in. I just put a sample number there. And you'll calculate your percent of heights. Now, if you did this out of 20, that's great. But what I want to talk about is calculating this out of a different total. So if we add in a person, and this person I just picked 72, so if this person is here at 72, then that would mean that there is 21 people in the group instead, which means this person, Ariana, would not be at the 25th percentile if the group was 21, because the 20 was part of how we calculated. So this would be a separate problem entirely, which is not really how you're going to see problems. So 20 was fine, but I want to talk about what happens if we change this to 21, because sometimes not nice numbers will pop out, and we need to know how to handle those too. So here, to count this with me, and you can just use this example and match it here for this separate weird thing. We're just going to count all the ones that are this direction. Okay, if you want, we know there's 21. There's 21, there's 20, so this would be 19. But you can count it this way as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, there it is. Okay, but I wanted to talk about how this looks. If you take 19 over 21, it's not going to come out to a nice value. And so I'm just going to jot down a couple decimals here, 0.905 about. And I'll just actually do a couple more, 90, since we'll have to move it, 476. Okay, when we're talking about percentile, we want it as a percent. And what you're going to do when you're rounding here is always percentile is represented as a whole number. And because the definition is less than or equal to the value, we're going to round this down. So even if this was 90.8, we're still going to round it to the 90th percentile. Okay, so this one here would be the 90th percentile. And your value, of course, would be somewhere out of this 20 that's a little bit different, assuming you were in the original set of 20. Okay, so there, your cumulative relative frequency. What I want you to do to the side, this is a running total of all your values. Okay, hopefully you noticed, because I already had this part filled in for you, you noticed that this 20 and this 25 were different intentionally because it's adding it up as you go. So here, 55 and 25 to get your 80, 80 and 15 to get your 95, and that means that this is always going to be 100%. And now we can talk about this graph. So you at this point will not have this red line, but your bar graph should look something like that with those values that we just talked about, the 5%, the 25%, and so on. And what we're going to do is talk about how to get the line graph from there. With a line graph, when you're drawing one out, the points themselves appear above the lines that are your scale markers on your x-axis. So we have to go put our markers there. But you'll notice on this that the height of the bar is where the right end point is. So I want you to make a note of that. Just put a point on the right side of your bar all the way through. And then you're going to say height of bar, wherever you have room, marked at the right. And then we're going to just connect those points with a straight edge. So side of your ID, side of a calculator, anything, but make about a straight line. And that straight line will let us estimate where values between your endpoints show up. Now, something that's weird about this graph on the bottom here that's a little bit off is it doesn't quite match up to the groupings that were in this table. And that's really the fault of the table, but because we calculated these frequencies based off this table, we want to make sure this matches. So it went 56 to 60. If we fix our graph here, 56 to 60 needs to look a little bit different. This would be 56, and remember the right is almost 60. So we are going to write 61. If we want it to go to 60 here, then the 61 would go in the next one. So essentially that just means all of these numbers are going to be shifted up by 1 to fix it. And you won't see something weird like that again, because in general, that should have been 76. In general, you get to choose the values from which intervals you want, and you'll choose nice ones. Okay, so with this, you should have estimated for 66 inches somewhere between the 20 and 40 mark. Okay, so around 30%, something like that. It says estimate, so I want you to make sure you have an approximately. And it's talking about and interpret the percentile. The definition of percentile is at or below. Okay, so at or below. And then it says estimate, interpret the 80th percentile. Okay, so this is going the other direction over from 80, figuring out where that dot lands down on 70 and actually 71 based on shifting over our scales. But again, as long as you say about, because it's an estimate, and then your interpretation is 80% of heights are at or below that number. Okay, it's always at or below 4 percentiles. And I'm going to take a minute to actually do the math for these so we can practice with percentiles how they're calculated. Okay, so we're going to go up and we're going to assume Mrs. Gallas was included in the original set. So this is just a student, but we're going to talk about 66 inches from our original data. Okay, since it's from our original data, it's got 20 people, we couldn't really estimate it from here because adding an extra point would mean new data set. So we're going to go look at 66. So I want you to go back to your dot plot for me and find where 66 lands. Okay, so it's right here. And we're going to pick on one of the humans in this set. Okay, it doesn't matter which one because we're going to count at or below. So at or below would be 1, 2, 3, 4, 5, 6, 7, 8. And that would mean 8 out of the 20 people, which would indicate the 40th percentile. Okay, so with our fixed number of 66 here, This right here was the 25% of where it would have landed. You approximated 30%. The actual percentile is the 40th percentile. Okay, same thing we can do on this one, estimate the 80th percentile. How this works is we're going to take, since it's the 80th percentile, we're going to take 0.8, find 80% of the total number of students, which is 20, to work backwards. Okay, so for this one, you could honestly just throw it in your calculator, times 20, and it's telling you not the score, but the student in the line of students. So this would mean the 16th, and I want you to write this 16th person. It's not always people, but that's what we're talking about here. And then we go back to our dot plot, and we look for that 16th person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and it ended up being 70, the height of 70. Which is what the graph approximated for us. Okay. Next thing we're going to do is talk about Z-scores and what they mean. Okay, so this is your second activity. What I want you to do is pause the video and go all the way right before the notes, and that's where this video is going to stop. Okay, we're going to go over this stuff, and then we'll talk about these notes and the rest of the practice next class. Okay, so pause the video and answer through question number 6 for me. Right, so the first thing you were asked to do was do the percentile, and that was from what we just practiced. So 65 was here, 1, 2, 3 people, 3 out of 20 is the 15th percentile. Okay, and then what we're going to do is talk about language of direction. So hopefully you got 15 points, but I want you to make sure you talk about that that was below the mean. Okay, so we'll just put that together. And then it asked how many standard deviations. Okay, so a standard deviation was 10, and we want to relate 15 points to that 10. So 15 over 10 is 1.5. Okay, over 1 standard deviation because we were over 10 points, and we were over by 1/2. Okay, so 1.5 standard deviations, and again, it was below the mean. This thing right here, I want you to put a note next to, is defined as a z-score. When we change points to the number of standard deviations, you are finding a z-score, and that allows us to compare unlike groups. We can take something with points and something with minutes and compare them because it changes to standard deviation, which is a measurement that can come up from any set. Okay, so this next one was the same kind of idea here. It wanted to talk about Marty, and his percentile was the 80th percentile, but the next question referred to how far above or below the mean again. So this time it was above the mean for Marty, and then 8 over 10 is 0.8 standard deviations, and one more above the mean. So if you left out the word above here, or didn't compare it to the mean, go ahead and add that on now. The last thing you were asked to do for this little section was to write the formula for a z-score, which I told you related back to the number 2 and number 4 that you did. Okay, so this thing was the z-score itself, and all you had to do is figure out, well, how did I get that number on top, and how did I get that number on bottom? Well, the number on top just subtracted from the mean, and the number on the bottom was our standard deviation from the set. Okay, but what I want to point out here, if you have these flipped around in the wrong order, you need to fix it. And we'll put to the side the actual formula with symbols. Okay, so the value is some number x in your set, and usually that's xi to represent a particular term. The mean, we usually write x bar if it's a sample, and then standard deviation is just s for a sample. Realize that you can see mean as mu if it's a population, and you can see sample or standard deviation as sigma if it's a population versus a sample. Okay, but this will be the most common version. It's not the absolute value. That's something important. When we're doing a z-score technically, you're going to get a positive or a negative value. So this right here, and I want you to write it to the side here, was a positive 1.5. Okay, and it was standard deviations. You can abbreviate that. And it was positive, so that indicates above the mean. This right here, the actual z-score, if we subtract in the correct order, is a negative 0.8 standard deviation. And we won't say negative standard deviations. Instead, we'll say that the score was 0.8 standard deviations below the mean. Okay? And the very last thing is just checking here that you included that language. So this is just interpreting how I want it. You're going to give me context. So you'll have to say the score. In this case, it was for Goldie. So Goldie's score. And then you're going to say is the number. The label is always standard deviations. And then I want to see the word above or below based on sign rather than positive or negative. And that's it. We're going to cover the rest next time and get some more practice with the z-scores, percentiles, and cumulative relative frequencies.